How's it going, Sully? What do you got to say?
I'm a flat earther, bro.
Oh, okay. Why?
We measure. Sorry, there's a car going past me. We measure it flat through plane surveying, and then we build infrastructure off of flat measurements. So the Earth cannot be curving.
Okay, so there's a difference okay, can two things or actually, you know what? Let me backtrack. Are you done?
I mean, just as long as you understand my argument, right? Like we measure the Earth using plane surveying, where curvature of the Earth is effectively disregarded because we measure it in short increments, typically 500 feet to 1,000 feet, and then we hop to a different location and we do the same thing. And
okay,
if you understand my argument, you can attack it if you understand it.
Yeah.
Okay.
So the thing is, the reason why we do flat plane usually is to get parallel structures. When you're talking about 5 or 1,000 feet, curvature is it's negligible.
I agree. But the problem is that we take those measurements, like we measure 500 feet to 1,000, okay, and then we move to the location that we measure to. We hop to the next location, right? Another 500 feet, another 500 feet, and so on and so forth. And then we calculate all that data up together to build bridges, tunnels, pipelines, gas lines, infrastructure as a whole. Curvature of the Earth is literally disregarded.
Excuse me, can I interject real quickly?
Yeah, go ahead. People are welcome to talk if they got something to say.
So,
just one mic at a time. I will enforce that, and if you end up talking over somebody else or this ends up becoming an argument, everybody gets removed.
All right. You're a flat earther, right?
Yes.
Can you explain why to me?
Are you going to attack my argument?
Yeah.
He did just explain it. So, yeah.
I'm with physics, so
just give some evidence as to why the Earth isn't flat, because he already said it. I don't want him to be talking twice. It's fine.
Okay, so you said that the measurement with the plane, right?
I'm sorry.
So you said that 500 to 1,000 measurements with the planes, and then they move spot to spot, right?
Yes, and they disregard curvature of the Earth every single time.
Yes. Well, curvature is measured in radians per meter. Okay.
There's also a formula for 8 inches per mile squared, which is an agreed upon approximation, parabolic approximation.
Yeah, it's an approximation. So
yeah.
Either way.
But it's disregarded entirely.
Yes, but when you are at a scale that small, it is very easy to
okay, so this is why I always have to ask, and I'm sorry to interrupt you, I truly am, but this is why I always have to ask if people fully understand my argument, because it's the equivalent of taking a piece of, like, Hot Wheel track and putting it next to another piece, and then next to another piece, and next to another piece, and next to another piece, and all of these pieces are flat, right? And then you're trying to tell me that, like, it's negligible, but, like, 500 feet plus 500 feet plus 500 feet, eventually you'd get to 10 increments of that would give you a mile. If you do 20 increments of that would give you 2 miles. So the curvature would add up very quickly, right? And the fact that we build, like, 100-mile long bridges, several 100-mile long pieces of infrastructure like pipelines and gas lines,
that's what I'm doing.
It wouldn't add up quickly. I'm sorry.
It would not add up quickly. Okay.
Yes.
Okay. So what's 500 plus a 500?
500 plus 500, 1,000.
Okay, what's 500 times 10?
The radius.
What's 500 times 10?
It's 6,000 kilometers.
I get that. What's 500 times 10?
500 times 10, 50,000.
No, 5,000.
500. I mean 5,000. My bad.
Yeah. So that'd be about a mile. So just in 10 measurements, you're already at a mile. In 20 measurements, you're at 2 miles nearly, right? So this does add up very quickly. You're not attacking my actual argument. You're not saying how we actually compensate for curvature. You're just saying that we don't have to. And I agree, we don't have to. The Earth's not curving.
Well, okay.
We do have to compensate for it.
When do we do that?
You don't have to account for curvature on a small axis because of the short distance. Okay, if I were building... So, the Boeing Everett factory, okay? Okay, hold on. The Boeing factory in Everett, Washington... It's a very big building. It was so big that it had its own internal atmosphere and its own internal weather. Okay, that's how big the building is. It is freaking massive. They had to account for what you're saying isn't accounted for with that building.
How did they do it?
I'm not an architect. I don't know. But one thing that I can say that they do account for mathematically is like if you're talking about like battleships or like any type of naval ordnance,
Right.
they do have to account for the curvature of the Earth to land ordnance properly.
How do they
The
do that?
USS Texas had to do it. The USS Missouri had to do it. All
How do-
of the battleships in World War II.
How do they do that? How do they do that?
So they account for the 8 inches. They account for wind. They account for.
Can you give me a? Can you source that?
Yeah. You can look up. Let's see here. It was Willis Lee's ordinance. I don't have any stuff with me right now.
Because I've looked into sonar quite heavily, and they do this thing
sonar
called.
Is not that. Sonar is
Right,
not that.
but it's very similar because you're talking about naval, right? And of course we use sonar to navigate when we do naval. So
But-
during sonar, they do this thing called bathymetry.
No, hold on. You're
Oh.
we're talking about a liquid medium. We're not talking because like if you're running through liquid, you're able to propel whatever ordnance you have, aka.
I'm not
torpedo.
talking about that. I'm talking about bathymetry.
Excuse me, about your airplane argument, you cannot just.
We have
add
not even
measurements.
talked
You
about
need to
airplanes
measure
once.
something bigger.
We have not talked about airplanes once.
You have. Before, you have.
No, I
he
didn't. I
talked
said
about
sonar.
plane. He talked about planes, like as in a flat surface. That's what he talked
He
about.
said
Before, when
airplane.
you're talking about like measurements with planes. I'm just saying you.
No,
cannot add
no.
up.
PETA,
It's not
dude,
gonna work.
PETA, you're off topic, like severely. I don't mean to be rude to you, but you are. I was talking about sonar now, right? Which they
Yeah,
use
now
this.
you're
They
talking about sonar, but I'm
can I
talking
can I
about
steelman my own argument? Is that okay?
Yeah.
Okay, so we use this this measuring method called bathymetry, right? Which is as scanning the ocean floor, and you have to assume that sea level is horizontal because we map things out on a 3D Cartesian coordinate system, right? We assume Euclidean math. We assume that the water level, we use it as a reference point, as a datum, okay? We use it as a reference point, and we assume that it's parallel to the ocean floor. And we can map out the ocean floor up to 21 miles using swathing. And I've also read, I have like a whole slideshow presentation on this. It's very fascinating. Now, in 21 miles, I'm not going to crunch the numbers here, but there'd be quite a lot of curvature, and you simply wouldn't be able to map that to a 3D Cartesian coordinate system without compensating for that curvature, and you certainly couldn't do it using Euclidean geometry.
So, after you and the streamer are done with the argument, I would just like to make an argument against the flat Earth.
Well, okay, can you attack my argument, any of my argument that I've actually made, besides saying that the Earth is too big to
I'll
compensate for
attack your
curvature,
argument.
so we just treat it
21
flat?
miles, you said the curvature would be significant, right?
I'm sorry?
In 21 miles, you said that the curvature would be significant, no?
Yeah, at 8 inches per mile squared. Even at 10 miles, you're looking at over 600 feet, I think? 6,000 feet. No. What is it at 10 miles? It's like...
So think about it this way. So per mile squared means that the first mile is 8 inches drop, second mile is 8 inches plus 8 inches.
No, that's not what 8 inches per mile squared means. It's exponential increase over distance with the drop from tangent, right? So
Yes,
you would multiply the mile by itself. That's what exponents do.
No, that's no. It's 16. The first mile is 8 inches drop.
The second mile is 32.
24
The
inches
second
drop.
mile is 32. The third mile is 72. It's exponential. That's why it's called an exponent.
Okay, but
In higher math, an exponent isn't repeated multiplication. It becomes an infinite
Yes.
polynomial.
because fall distance, because it's also per second, so per second squared. The thing is that it's 9.8 meters, and then you add 9.8 meters to 9.8 meters on top of that. So
No,
it actually
you-
triples.
Oh God, you multiply the second. The amount of seconds, you multiply it by itself. You don't change the 9.81. You keep that as your constant variable. Then you multiply the per second by the, like if it's 5 seconds, you multiply 5 times 5, right? Per second, per second squared, right? Squared means multiply it by itself one time. That's literally what an exponent is. You multiply that number by itself. Are we really arguing rudimentary mathematics right now?
What's in here? Okay.
Yeah, maybe it's in there somewhere. Or you have to Google this? Oh my God. Oh my god.
The way, because I'm going off of the how. Let's see here.
There's no way he's Googling what exponents is. It's PEMDAS, bro. Oh my god.
Because I think that we're actually talking about the same thing.
We're trying
talking,
to. We're trying to, yeah.
We're talking about the same variables. What you're saying is correct, but the other thing is
Can someone in the chat do 21 times 21 times 8 and give me a rough estimate of how much curvature would be in 21 miles? Just for the sake of simplicity.
21 times 21 is 441 times 8 is 3,200 plus 328. So 3,528.
That would be inches divided by 12.
3,528, that would be about 30, that'd be like 300 feet.
Yeah. That's completely unaccounted for, mapped out on a 3D Cartesian coordinate system, assuming Euclidean geometry. He's still Googling exponents, by the way. You can do a lot of cool math in your head, bro. That's actually really impressive. I'm not going to lie. I used to be quick like that, but I let it go.
I'm autistic, so, I have trouble formulating my sentences, but I'm good at math.
Well, that's brilliant, actually.
So,
Did you figure out what exponents are? The guy who was in here, dropping a whole bunch of meaningless...
Principle. The way that I put it was the same way that you put it, just different.
No, you said you would add it to itself. That's not exponential. That exponential is
multiplication, but it's adding multiple times. It's adding on larger intervals.
No, you multiply it by itself. If you multiply 3 times 3, you get 9. But if you add 3 and 3, you get 6. You see how there's a big difference here?
Yeah, I'm with you. Repeated multiplication.
But
yes.
Hold on. You just messed up there, because if I'm multiplying 3 by 3, then I have to add 3 times. 3 plus 3 plus 3 is 9. Still 9.
What's 3? But if you add 3 plus 3, you get 6.
But that's not what we're talking about. That's you're
oh my god. Oh my god.
3 plus 3 plus 3, because you're taking 3 and you're adding 3 times.
I'm so glad that other people are watching this. That understand this. This is not this complicated.
I just make an argument?
No, you're arguing semantics about math.
Without you laughing.
No, my argument is not semantics. My argument is how to do math correctly. Your argument is you doing math incorrectly.
Did I not just explain adding in order to make a multiplication equation?
You don't add to do multiplication. You multiply to do multiplication. They have similarities. I'll grant it to you. There's similarities, right? They're both positive integers, right? But
okay.
It's different mathematical premise that you're using, right?
99 times 99 is 9,801, because you add 99 to it.
Okay, what's 99 plus 99?
198, but that's okay. That is a different thing. I'm adding 99 to 99 98 times. 9,801.
Dude, I'm gonna suffocate. This is insane. So 8 inches per mile squared, right? And nobody did the math for me. I think somebody said it was roughly 294 feet. That is assuming Euclidean geometry, right? 3D Cartesian coordinate system.
Yeah.
No compensation for curvature of Earth whatsoever. We map out the ocean floors using bathymetry, using this method primarily.
Okay.
We don't account for curvature in anything we do with the efficacy of sonar, microwaves, infrastructure engineering, plane surveying,
okay.
Aviation.
Sonar is not a necessary thing with curvature, because
it would be.
You're literally able to go that way. I'm able to go that way rather than having to arc.
Which way does the curvature of the Earth go? Which way does the curvature of the Earth go?
That way.
Oh my god. Oh my god.
Yeah, you're just arguing semantics. You're just being
Oh no, dude, I can't wait to post this. This is so funny. Oh my god.
Excuse me.
Yeah,
Can I
go
talk?
ahead, Peter. You say something now.
Let's see here.
Yes, thank you, Angel. Thank you very much.
Damn, my life is super
So the
popular.
argument is that we treat the Earth like it's flat and stationary for the efficacy of all technology and scientific data known to man. All mathematical data treats the Earth as if it's flat and stationary, but actually it's a ball. Trust me, bro. Right?
Okay, so here's the thing.
Mhm.
Let's backtrack. Okay, so
Sure.
okay, I need to get my bearings back.
Excuse me.
I'm just trying to I'm just trying to take into account all the stuff that was said. Okay.
Take your time.
I am trying to have an
What
actual
do you need
conversation
me
with
for?
you. Solely, I'm trying to have an actual conversation with you.
Dude, am I
know you
not-
keep laughing.
It's funny. Come on, it's just the shape of the Earth. It doesn't hurt anybody's
You're being
feelings.
an asshole. Okay? My point exactly.
It's funny, bro.
Can I talk? Just a question.
Yeah, I want to
Can
hear
talk?
what Peter has to say. He had a question for me.
Okay, great. So you
You got to stay in the application, brother.
Hey, Tiffany. By the way, any friends are welcome to come up.
Got to stay in the application, Peter. It's the only way we can have a conversation. Can't keep Googling everything.
Oh, no.
Host needs
No.
help.
Hold on. I'm trying to oh, he's already crashing out, Tiffany.
Am I? 1 in chat if I'm crashing out. 2 in chat if Tiffany's just a weirdo.
Let me see here. Okay. The thing is that so you were originally talking about planes or
No.
a flat plane. You were talking about a flat plane.
Plane surveying.
Yes, plane surveying. You were talking about that.
I was.
And then you were talking about sonar.
Mm-hmm.
Because that was apparently a defeater for military ordnance, which it's not.
We navigate using sonar, yeah, and radar.
We navigate using sonar through water. Okay,
Yeah, typically, yep. Mm-hmm.
water.
Yeah.
You can go through water. You can't go through ground. You can't go. I can't drill a hole with ordnance and then I can't make a quick route through ground without making a ton of infrastructure, having a vast amount of infrastructure to get there. That's the difference.
Not
Water
really
is a
seeing the
liquid.
importance of, when do we prove that the Earth is curving? When do we do that?
Okay. So, okay, actually, I'll have some questions to ask you then.
What?
So, how does the magnetic
My
field
God,
work on the flat Earth?
just shifting the burden of proof. When do we prove that the Earth is curving? There's an inertial.
I can prove it with other questions.
Oh, you can't make a
Because
statement.
you're not rationalizing
Uh-huh.
my side. You're not rationalizing PETA's side.
Right.
You're talking about your stuff, and then you're just laughing at us when we don't actually have a way of actually summarizing our words.
Victim mentality. Got you. All right. So when do we prove the Earth is curving?
Okay, how does the magnetic field work on a disk?
There's an inertial plane inside of every magnetic field, a plane of pure inertia. That would be where the Earth is, and then you would have the toroidal, the hyperboloid coming out from the center of just like it does on.
Show me an image of the magnetic field on the flat Earth.
You can look. Okay, so I'm explaining to you how magnetic fields actually work in reality.
I know how magnetic fields work.
Really, what's an inertial plane?
I don't know.
What's
the actual
centripetal
terminology there, but
divergence?
I know that there's lines between the poles that actually.
What is
interact.
centripetal divergence?
The fact that I am not privy to all of the terminologies.
Oh, you know how they work though? What's centrifugal convergence? What's that?
Okay. Yeah, you're just being an asshole. Just using it.
This is like day one magnetic field 101, by the way.
I don't actually study this shit.
Oh, you should. You said you know what it was, though.
Okay,
So when
there
I'm
we go.
explaining to you what an electromagnetic field is and the properties that make one up,
Sully, a bigger asshole than you's here now, dude. You little prick.
Yeah,
let's
that's
see if
good.
you run now.
I
Let's see
guess
if you
I'll
run
have
now.
no
I can
choice
keep
but
up
to
with your
like
butt. I can
leave.
keep up with your mouth.
You,
Or you could leave.
I could
Or just
leave.
sit here and be
All
a little
right,
dick.
everybody have a good day. Anti-flat earthers on the
Later.
rampage today.
Peace.
I got my clips. It's all
See
good,
ya.
bro. Take care of your fat self.
all you're-
Have a good day.